So, what really powers our modern world? I mean, yeah, we think of code, we think of the cloud, but today we're going to deconstruct the unseen engine that physically moves everything. It's the tech that's hidden in plain sight, from the fan in your room to the biggest machines on the planet.
So here's the plan. We'll kick things off with just how important these motors are. Then we're going to crack one open, metaphorically, to see how it works. After that, we'll get into a huge problem they've had for over a century, look at the old and new solutions, and see why the fix is a total game changer for a sustainable future.
All right, let's jump right in and talk about just how fundamental this technology really is.
You know, it's easy to think that software and the internet are what drive everything forward. And they do, in a way. But underneath all of that, there's a much more basic force at work. A piece of hardware that literally moves our world. It's this guy, the AC induction motor. These things are the absolute workhorses behind the scenes. They are the backbone of all of modern industry. You find them everywhere, in pumps, compressors, and those huge HVAC systems that keep all our buildings running.
So how in the world does this essential piece of tech actually work? Well, it all comes down to a really beautiful dance between physics and engineering.
Okay, so it really boils down to two main parts. You've got the stator, which is the stationary outer part with all the copper windings, and then you've got the rotor, the part that actually spins on the inside. Now, the magic here is all in the physics. A magnetic field from the stator makes the rotor spin without ever touching it. It's a totally contactless design, which is just brilliant.
And this is how it happens, in this elegant three-step process. First, AC power flows into the stator and creates a magnetic field that spins around. This spinning field then induces a current in the rotor, which, you guessed it, creates its own magnetic field. And it's those two fields pushing and pulling on each other that creates the torque and makes the whole thing spin. Simple.
Now, it gets even more interesting when you look at the stator's copper windings, because it's all about trade-offs. You can use a simple, cheap, single-layer winding, and that's perfect for small motors. But if you're building a huge industrial motor, you need a more complex and expensive double-layer winding to handle the higher voltage and get better efficiency.
And it's not just the stator. The rotor has its own flavors too. The squirrel cage design is by far the most common one out there. Why? Because it's dead simple, incredibly tough, and you basically never have to do any maintenance on it. Then you have the wound rotor. It's way more complex and costs more, but it gives you something the squirrel cage can't, a way to control its starting torque and speed.
But, and this is a big but, for all of this elegant engineering, there's a huge fundamental problem that engineers have been wrestling with for decades. Turns out the simple act of starting one of these motors, well, it's not so simple.
So 5 to 7 times, what is that? Well, that's the insane surge of electrical current, 5 to 7 times the motor's normal running current, that it draws just to get going from a dead stop. And that puts a massive strain on the whole electrical grid.
This massive jolt is called inrush current, and it is a serious problem. It's what makes the lights flicker when a big AC unit kicks on. It can trip circuit breakers, and it puts this huge stress on the motor and everything else connected to it. So to fix this, engineers came up with something called reduced voltage starters.
Now, for a long time, you basically had two main choices. The star-delta starter was the cheaper option, but when it switched from start mode to run mode, it created this brief power interruption that caused its own set of problems. The other option, the auto-transformer starter, gave you a smoother start with more torque, but it was way bigger and a lot more expensive.
And you don't have to take my word for it. Listen to what this one engineer, Jay Rafe, said in an online forum. He pointed out that people often pick the cheap star-delta starter, but the hidden long-term costs from the electrical stress it creates always make it more expensive in the end. It's a classic case of getting what you pay for.
Okay, so we have this age-old problem. But what if? What if there was a way to completely solve the starting issue and get total control over the motor's speed at the same time? Well, that's where modern electronics completely changed the game.
Enter the variable voltage, variable frequency drive, or as everyone calls it, the VFD. This is a super sophisticated electronic controller that just fundamentally changes the relationship between a motor and its power source.
So remember that massive 5 to 7 times inrush current we talked about? With a VFD, poof, it's gone. It just disappears. By starting the motor at 0 voltage and 0 frequency, and then gently ramping them both up together, the VFD gives you the smoothest start imaginable, totally eliminating that electrical jolt.
So how does it do it? What's the secret sauce? It's actually this beautifully simple idea. The VFD's whole trick is to maintain a constant ratio between the voltage and the frequency it's sending to the motor. As it increases the frequency to make the motor spin faster, it also increases the voltage in lockstep. This constant V over F ratio keeps the motor's magnetic field strong and gives you stable, reliable torque no matter how fast or slow it's running.
And this isn't just some clever engineering fix. This level of precise control completely transforms what we can do with electric motors. And it unlocks these massive benefits in efficiency and performance.
I mean, the advantages are just huge. Instead of running a fan at full blast all the time, a VFD can slow it down to exactly match what's needed, saving a ton of energy. That smooth control also reduces all the mechanical wear and tear, so your equipment lasts longer, and the whole system just runs quieter and way more efficiently.
So you see, this is way more than just a better starter. It's a fundamentally smarter way to use energy. In a world that's so focused on sustainability, being able to optimize the performance of the billions of motors that are already out there, well, that's one of the most powerful things we can do.
And that kind of leaves us with this one big final thought. As we keep electrifying everything, our cars, our industries, our homes, maybe, just maybe, one of the most important tools we have for building a more efficient, sustainable future has been sitting right in front of us this whole time, just waiting for a little bit of intelligent control.